Have you ever wondered how your phone seems to read your mind, finishing your sentences before you even think of the next word? This predictive magic is often powered by a type of artificial intelligence called a recurrent neural network, or RNN. Imagine a glowing digital brain, a complex structure designed to understand sequences, like the words in this very sentence. As information visualized as a stream of light particles flows through this network, it tries to remember what came before to predict what comes next. However, these traditional networks have a critical weakness. As the information travels further, its memory starts to fade, a problem known as the vanishing gradient. The light of past context dims, and crucial details are lost, making it impossible for the network to remember the beginning of a long story by the time it reaches the end. To solve this digital amnesia, researchers developed a brilliant solution: the long short-term memory cell, or LSTM. Think of this not just as a single neuron, but as a futuristic data core, a sophisticated upgrade to the brain's memory system. At its heart is a memory conveyor belt, a special channel called the cell state that allows information to flow straight down the entire chain, completely unchanged if needed. This preserves the memory over long sequences, preventing it from fading away. But how does it know what to keep and what to discard? That's where the gatekeepers come in. The LSTM cell has 3 intelligent gates that act like bouncers at an exclusive club. The forget gate decides which old information is no longer relevant and should be thrown out. The input gate determines what new information is important enough to be saved to the cell state. Finally, the output gate carefully selects what part of the memory is needed right now to make a prediction. Together, these gates give the network a powerful, dynamic memory. The impact of this innovation is all around us, woven into the fabric of our digital lives. When you use a translation app, LSTMs are working behind the scenes, remembering the grammatical structure of the first half of a sentence to correctly translate the second half. When you ask a voice assistant a question, LSTMs help it understand the full context of your query, not just the last word you spoke. They can even be used to analyze financial markets, with charts animating as the network predicts future stock prices based on decades of historical data. In each case, the LSTM's ability to retain long-term dependencies is the key to its success, allowing it to perform tasks that were once impossibly complex for machines. While newer and even more powerful architectures like transformers have since emerged, often building upon these foundational ideas. It was the LSTM that truly revolutionized how machines understand sequences. It taught AI how to remember, bridging the gap between short-term processing and long-term context. The LSTM network was a monumental leap forward, and its core principles continue to influence the development of intelligent systems, ensuring its legacy as a cornerstone of modern artificial intelligence.